Students, we are going to solve the second part of Irodov problem number 1.51. What is the question? A rotating disk moves in the positive direction of the x-axis. Find the equation describing the position of the instantaneous axis of rotation if at the initial moment the axis C of the disk was located at the point O after which it moved. Now, first part we already solved. We have to solve the second part of this question. What is the question? This is a disk. Initially, the axis of rotation of disk is at origin. Now, the disk is initially with a constant acceleration w. This disk is moving with a constant acceleration w. Now, instead of w, I write the acceleration as a symbol a and the zero initial velocity. So, at t equal to 0, v equal to 0. Now, while the disk rotates counterclockwise with a constant angular velocity omega. At this situation, disk is rotating in a counterclockwise direction with constant angular velocity omega. Omega is constant means alpha is 0. Now what happened? This disk move with a certain time. As the time go, this disk move as well as rotate in counterclockwise direction. We have to find the equation of instantaneous axis of rotation's position. So how to do that? To find the location of instantaneous axis of rotation at any time t, we have to find at least velocity of 2 points of the disk. So how to find the velocity of 2 points of disk? Now this is the situation at t equal to 0. This is the situation at time t. So at time t, what is the velocity of the center of this disk? To calculate velocity at initial speed is 0, acceleration is a, so I can apply the formula of kinematics. V should be equal to u plus at. As u is 0, so v should be equal to a into t. So at time t, the velocity of this center is in plus x direction having magnitude v into t. So this is the velocity of one point. Now you can take randomly any point and find the velocity of that point. For simplicity, I just calculate the velocity of the lowest point of this disk as calculated in the first part. Now, what is the velocity of this point? This point constitutes two parts of velocity, one due to translation and other due to rotation. What is the velocity due to translation? The disk is translating with velocity vt at this moment. So due to translation part, the velocity is vt, yes, and due to rotation, the disk is rotating with constant angular velocity omega. So the velocity at this point due to rotation is omega into r. So this is the total velocity of this point. So the total velocity of this point is vt plus omega r. Okay, now where is the instantaneous axis of rotation? Instantaneous axis of rotation is always at a perpendicular line to the velocity of particle. So instantaneous axis must be on this line. On this line. Now how to find? To find, just join the top of these two velocity vectors. Now what it said that the velocity of this point is this length, velocity of this point is slightly less than this, velocity of this point is again slightly less than this, and velocity of this point is vt. Similarly, the same pattern will be continue, and at this point, if I continue the same straight line, velocity will decreases in the same proportion. So this is the position of instantaneous axis of rotation. Now I call this distance as y. I call this distance as y. So how to find y? To find y, use this triangle. This is a right angle triangle, and I call this angle as theta. So tan theta should be equal to, in this triangle, tan theta must be equal to, this is the perpendicular part, so it is Vt divided by this base length y. Okay, use the same tan theta for this bigger triangle, bigger right angle triangle. So tan theta equal to this perpendicular part. The perpendicular part is Vt plus omega into r, and this total part. So this length is y and this is the radius of the disk, so it is r. So it should be equal to y plus r. Now apply the componendo and dividendo rule to this ratio. For that, what I am doing is, from this upper part I subtract this upper part. So Vt and Vt should be cancelled out and it should be equal to omega into r. What you do to do the upper part, do the same to the lower part. So from this part subtract this part and it should come out r, which is equal to omega. So from this equation Vt by y should be equal to omega. So y should be equal to, oh not, this is Vt, not Vt, At. Oh, this V equal to At, so it is At, okay. This is At, V equal to At. So this is A into T divided by omega. So this is the y coordinate. This is the equation of y coordinate in terms of time. What is the x coordinate? This distance is the x coordinate. And how to calculate this distance? Just use the formula s equal to ut plus half at square. U is 0, so half a t square. So this is the x equation with time, this is the y equation with time. So I have to calculate a relation between x and y. So I just write t as y omega divided by a and put into this equation. So what is the final equation? X should be equal to half a into a square of time. So a square of this number. So it is y square omega square divided by a square. So a and a should be cancelled out. So it should be equal to half y square omega square divided by a. So the equation is y square omega square should be equal to 2ax. So y square equal to 2a divided by omega square into x. So this is the equation of parabola. So the instantaneous axis of rotation of this problem vary with parabola. What it means that initially there should be an instantaneous axis of rotation on this line and it vary with parabola like this. This is the pattern of movement of instantaneous axis of rotation. So this is the answer.